Good morning. Today I'll talk about evaporative towers and their applications in cold climates, specifically in particularly chilly weather conditions. We have created evaporative tower applications that have been installed in environments that are decidedly cold. Let's talk about environments that go below zero at significant levels, minus 20, minus 30, minus 40. Just to give you an idea, these are applications that ended up in steel mills in regions where there are significant temperature variations. So you have hot summers, but definitely cold winters. Evaporative towers are machines installed outdoors, so they must work in extreme temperatures to ensure reliable operation in all weather conditions. Typically, they are designed and built taking into consideration the worst conditions, namely the summer conditions, because they have to provide cold water, so they need to perform at their best during the hot season. Being towers that work for industrial processes, they must be able to work 365 days a year, so even during the winter season it is extremely cold. The issues primarily stem from environmental conditions, specifically when these conditions decrease to exceptionally low temperatures and are utilized to execute certain maneuvers or implement particularly significant precautions. Firstly, there are antifreeze resistors in the tank that maintain a minimum temperature and prevent the water inside from freezing if the pipe stops. As long as the system works and the tower is functioning, overall we don't have major problems. The water may reach 40 degrees, 30 degrees from the process, and it is always circulating, so it is unlikely to freeze inside the tank. In any case, it is possible that we may need to halt the process, pause the tower for maintenance, or during a holiday break. And if this happens, the water inside the tank could freeze. When we have tanks of very high dimensions, the resistances are no longer sufficient. Very often, steam pipes are inserted, with a steam, let's say, usually exhausted, that comes from secondary processes and is discharged into the tank through what is called slang bubbling. Other precautions concern the circulation of water in the tower. As the temperature drops, we can stop the fans because we will need a lower heat exchange efficiency, so we can either stop the fans to cure, or if we have electronically controlled fans with inverters, we can decrease the speed until we stop them when the chimney effect of the tower is sufficient to cool the water. The lower the temperature drops, the more excessive this chimney effect is, even for the thermal loads we have in Valle della Torre. Next, don't pass water through tower, but bypass it directly into tank to complete the next step. To prevent water from freezing inside the exchange packs and completely clogging them, thus obstructing the exchange packs with ice, which is a serious issue, and weighing them down, ultimately causing them to collapse inside the tower, measures are taken. If the temperatures continue for an extended period, an additional precaution that can be implemented is to install partitions on the louvers and subsequently shut the air intakes to further restrict the influx of air into the tower, which may cause the water flowing or dripping on the fill packs to freeze. Let's say it's a series of precautions applied to the towers in this operational context. If interested, contact us. We could give interesting suggestions. Good day all, and thank you.